Right, hello, welcome back to another video. So today we're going to be continuing with our blueprints series. I'm going to be having a look at line traces, also known as path traces or sometimes a raycast. It's something we can do within the engine where we draw a line between 2 points and we basically just see if we hit anything. So we use this for AI, weapons. Quite often you have a raycast or line traced weapon if you're doing things like pistols or simple kind of like ray guns, and we can use them in our construction scripts to place objects around, and that's what we're going to be having a look at to start with. So if we start with a new blueprint, it's going to be an actor blueprint, and I'm going to call it line trace. I'm just going to make a copy of this in the world somewhere like this. So straight away I'm just going to jump over to the construction script, and we're going to use this this blueprint to basically just spawn a cube on the floor, but we're going to use a line trace to check where the floor is, and so it will deal with kind of like an uneven surface. So firstly we're going to do our line trace. So if we start here, we type in line trace. There's a few different options we can do. Firstly is a line trace by channel, by profile, or for objects, and then we can also do a multi-line trace. And the only difference here is a line trace will stop as soon as it hits something and then just stop. A multi-line trace will continue and give you all the hits. So if you're doing bullets that had penetration, you could work out whether it went through a wood wall first and then hit an enemy further on. So we'll just start by doing line trace for now. So by channel, what does that mean? Well, the trace channel here is looking for the collision channel. So in this case, it's looking for the visibility channel by default, and we could swap this to be camera. So we'll leave it on visibility for now. So this is going to be using the collision meshes of our scene to work out what it's colliding with. And we can preview this up here if we go to the player collision and visibility collision. So this is the two things that we've got going on. I'm not going to get too much into it, but quite often you have one set of collision meshes for your gameplay, and then another set of collision meshes for your camera, because it wants to work in a slightly different way. But this is how we can preview what we're seeing, and it's just a simplified version of the scene. If I bring in a cylinder, it's probably actually just using the geometry, and isn't it, on the cylinder. Let's bring in the chair and see whether that's got collisions. What that collisions are like. Static mesh. Okay, so there we are. So the collisions for the chair, not super accurate. Be good enough for player collisions. Same here for the table. And so depending on what kind of collisions we're using, you get different settings. And in this case, we're just going to do a line trace for the visibility channel. So that's actually what we're seeing, what we're rendering. If we open up any static mesh, we can see our collisions here. We've got two sets of collisions, simple collision and complex collision. So complex collision is going to be what we're going to be tracing towards, the visibility, what we can actually see, and it'll allow us to do things like shoot bullets through the bottom of the chair here, through the gap. But if we were making a game where we had like sort of a physics-based grenade, we might not be able to throw the grenade through this gap because the physics mesh maybe doesn't match. So very simplified discussion of sort of collisions and physics. Can get very complex very quickly, and that's not really what we're focusing on today. So hopefully that's enough of a description. So here we are back with our line trace, tracing on the visibility channel, and we've got start and end. Well, I want this to start at the root location of my blueprint. This is going to be from the blueprint down, and so I can do a get actor location, and if I don't plug anything into the target, it's going to refer to itself. So that's referring to this blueprint, and that's going to get the location of where the blueprint is in the world. Now I want to do a line trace down, so I know that I want to take this start location and I'm going to add a value to it to create an end location, and I can do a vector plus a vector, and that's going to allow me to just kind of offset how far my my trace is going to be. And I'm going to just do -500 in Z, and we'll see what that does for now. So I've got a debug drawer here. So this will work. This will take my start and end. It's not going to do anything because I've not got any further code. If I change the debug here, I'll put this just for duration. So you've got different options here. 1 frame for duration, which I think defaults to 2 seconds, 5 seconds, there we are, in the expansion extra settings bit, or persistent, and that's just going to be there forever while that version of the game is running. So we'll just do for duration, we're just going to do a 2-second duration, not only 5 seconds, 2 seconds, and then we'll get our lines drawing. Might have quickly seen it there, this blueprint. As I move this, it's going to do that line trace, and you can see it's drawing a line down in the Z-axis because that's what I've told it to do, and where it hits, where it creates a hit, we're getting this little red square, and then it is showing me the rest of the trace, but it's not returning any further hits. If I did 2 floors, because this is just a single line trace, not a multi-line trace, it's just going to return that first value. And that's sort of it. That's exactly how it works. We give it a start and an end, trace it along, and then we get our hits. So we get 2 return values, or 2 data nodes that come with our line trace. One is just a Boolean. If there was a hit, it's true. If not, false. So in our case, I'm going to spawn a mesh at the hit location, and I want to do this only if there is a hit. So I'm going to do a branch in here and say, if there's a hit, then carry on. If there wasn't a hit, well, that's fine. Our blueprint's flying in the air, or it's run out of space here. I don't really want it to spawn a cube if there's no hit location, and so I'm not going to do that. I'm going to use that Boolean true and false value to determine whether I want to hit. Now, this out hit, this is a custom data structure. This is giving us all the information about the hit. And down here at the bottom, we've got this option break. Whenever we're dealing with custom data structs, which we'll go into in more detail in the next video, I think, we have all this data contained in one object, or one kind of data type. We want to break that out and get more information, or get those component parts. So this is all the information about the hit that happened. And some of these things hopefully will be sort of self-explanatory. Hit actor, well, what did we hit? We can see what it is. If you were making a gun and you wanted to have friendly fire, you'd probably put a check in here to see, have you hit a friendly actor or have you hit an enemy actor? If so, do damage or don't do damage. And so you can build your friendly fire system off that part of the hit results. Location and normal. This is the location where the hit has happened, and then also the surface location, or the sort of the angle of the hit, and that's what we're going to be using here to create our spawn. You might notice there's location and impact point, and then normal and impact normal. So because we're just doing a single line trace, these are actually just the same. Doesn't matter. One thing we can do, which we'll have a quick look at now. We can also do a sphere trace. So rather than doing a line trace, if I do a sphere trace, and I'll do the same things here and put in the same inputs and outputs, or the same kind of start and end on the trace, and debug this as well. So this will do a, plug that in, yeah. It's not giving me the full sphere. That's because my radius is set to 0. So what this will do a sphere trace, and so it will fire a sphere along the location. And in this point now, my impact location might not be the same. So the impact location, it says here, if this was a swept shape test, well, this is a shape test, this is a sphere test. This is the location where we can place the shape in the world where it will not penetrate. Location of the actual contact point of the trace shape with the surface of the hit object, equal to location in the case of initial overlap. So if you're using sphere traces, there's a difference between these things because the object has a bit of an impact, but in our case we're just using line traces. I'm not hugely experienced with using sphere traces. Generally with the stuff I've done, it's always been a line trace, but that is at least why there are 2 different outputs here that seem to be the same thing, because in this case they actually are just the same thing. So that aside, over, what have we done? Well, we've done our line trace, we've hit the ground, we've definitely made a hit, got true, and I'm just going to do a add static mesh component. and I'm just going to spawn cube. Let's do, I don't know, cube. That's probably a thing. So I've one with the world grid on. Fine. And where do I want to do this? Well, I've got a transform here. I'm going to split that open to access the three things inside of it: the location, rotation, and scale. And the location, I'm going to plug into location, and then the normal, I'm going to plug into rotation. And hopefully Unreal is going to work out that this impact normal direction I want to convert into a rotation, and it's going to do it here with this rotation from X vector. And if I compile that, have a look. Well, we've got a result. It's maybe not the result we need. What's happened here? Well, we have to worry about our spaces. So in this case, the sphere trace is happening and returning a world location, and then we need to convert that back to be a local location so that it'll be relative to the blueprint center. And so if you have a look, if I place this blueprint at 0, 0, 0, and then move my floor down appropriately, and then do that line trace, this now looks correct because there's no transform here being applied. But as I move this across, hopefully you can see this has now got a transform of 200 or nearly 200 next, and this has had that same transform applied again. And so we're not dealing with the right objects in the right spaces. Luckily that's very easy to do. We can do an inverse transformation, inverse transform, and I'm going to do inverse transform location. And what this is going to do is we're going to give it the transform matrix, or the transform of this blueprint and this location, and it's going to work out how to convert that back from local space, or from world space to local space. So if I do get transform, get actor transform, get actor transform, and this again is looking at the self. So this is getting the transformation of the current blueprint and then unapplying it to this location, and that will give us our correct location in local space. And now when I move my blueprint around, you can see it doesn't matter how my where my blueprint is, it's always taking that information and doing it in local space. Very cool. Currently this surface is really flat. Well, we did put in a rotation and the tangent as well. Notice that I've updated my floor, but I haven't updated my line trace. So when you're dealing with construction scripts, it's only going to run when you're moving your object. So every time you move the object, you actually delete the previous object, create a new one in the same, or in the new place, and that reruns the construction script. So every time you move, it reruns the construction script. But if I then went in and updated this, that won't have rerun, and we're getting this floating cube. And so you go back in here and move it and it'll rerun. Or you can make a script and that will rerun it without having to move it if you so wish. But what's it done? Well, it's taken the surface normal into account. So we plugged our cube down and it's hit the surface normal correctly with our rotated surface. If we go over the chair, it's going to jump up and round and see, we are doing that line trace on the collision mesh. And you can see that referring to the collision mesh there. So if I change that to camera instead, is that going to work on the actual render mesh? No, it's not. There we are. Trace complex, that's what I'm looking for. Trace against the complex collision rather than the simplified collision. So this is going to be more expensive now, but it's going to follow that surface of that chair correctly. So there we are. That's what I was missing to get that collision to work properly on the surface of the chair there. So this is the collision channels then. So every object in its collisions has a whole load of information, trace responses, visibility in camera, and there's a whole set of collision settings which I won't go into now, but we'll maybe do in a future video. If you want to do a trace complex for the actual complex collision, what we'd also call the render mesh, we enable this. Otherwise, we can use the collision mesh if this is disabled. Cool, very cool. Obviously, we can fire these off at runtime. Traces aren't too expensive. You do want to avoid doing them too often. If you're doing traces on tick, they can very quickly add up to be expensive. Similarly, if you're doing an arc, you might want to define an arc by multiple traces, and then you're doing kind of like 5 or 6 traces per frame. They can start adding up, but they're not particularly expensive compared to some parts of code. You can also kind of do similar things with collision checks. So collision checks, I think, are cheaper than traces, but I'm not a programmer, and so always get your scripts checked and debug and profile to make sure that you're not doing anything too expensive. But for a simple collision check for placing objects, a line trace is probably pretty good, and you get some quite nice results. Couple more things before we leave this lesson. So we've done a line trace by channel, and that was using that collision channel that we just mentioned. You can also do a line trace by profile. So this would be using profile. Okay, not the one I was expecting. We can also do a line trace for objects. Here we are. This is what I was looking for. And so you can go and you can create traces based on specific object types. And so if I make an array of object types, so we can say only trace for static objects or dynamic objects, that kind of thing. And you can tell it to ignore specific actors as well. So if you wanted to be able to, mentioned friendly fire earlier, if you wanted to ignore friendly actors, you could create kind of like a way of being able to shoot through your teammates, as it were. And we can look for specific objects rather than specific collision channels. Line trace by profile, not sure how this one works. Maybe have a look at the documentation. Maybe check out this guy video, really great series there. Ray trace against specific profile, return the first blocking hit. Yeah, so what does it mean by profile? Traces overview. Trace by channel object type. Line trace by profile is quite a new thing. So yes, here we can do shape traces, cubes and cylinders, capsule, sphere and box. Okay, coordinates from trace. Not sure what that does. I'll have to have a dig with that and see. If anyone does know what the line trace by profile does, wants to kind of pop that in the comments, that would be really helpful. And then the last thing I wanted to point out here, so support UV hit from hit results. So this is a project setting that can be enabled if you're doing something like dynamic blood splats on a character. So when you shoot them in the leg, they get a sort of damage there. You might need their access to UV result or the UV hit. This isn't enabled by default because it can be a little expensive. So if your project doesn't need it, then probably better not to have it. But at the same time, it's quite nice. So you can go into the project settings, turn on the support UV from hit results, and then you'll be able to get the UVs in that break hit result here. You'll also be able to get the UV position, which I think will probably require a restart of the engine. But let's have a look. Project settings. UV, support UV from hit results. Yeah. Just restart that and see if that gives us the result we want. So yeah, they're incredibly powerful. Some ways I've used them, kind of lightning. Quite often lightning bounces around and impacts this sort of the area around it. And so you can do some line traces that way. I did a thunderstorm once where I did a few line traces from the sky to try and find a kind of high point, because obviously lightning strikes up above, which was quite nice, and a few other kind of creation blueprints. So placing objects around. Did that not save? Did I not save? Doesn't look like. Okay, well, let's have a quick look at this. Remember to save your work before you restart the editor, as apparently it doesn't tell you to do it for you. Line trace by channel. Break. Find collision UV. There you are. And so you can get the UV value from your hit result if you need to then get your position on a mesh, which can be really powerful. So yeah, unfortunately that isn't there at the end. I might just quickly recreate that after the video, just to include it in the project. But yeah, line traces, really powerful, really easy and kind of complex, and a dynamic way we can control how actors are spawning in relation to each other, and understand the world around them a little bit more. So do check them out, have a play with them. A little bit more complex than some of the topics we've covered earlier, but hopefully not too hard to get your head around. If you do have any questions or comments, or if you do know what a line trace by profile is, and you'd like to help educate me as well, that would be great, and I will see you all next time. So big thanks to all my patron supporters for keeping the channel going, and yeah, any questions, comments, let me know, and I'll see you all next time.